Okay, so we have our three new derivatives of inverse functions, which I hope are working their way into your collective memories here a little bit. We have the derivative of arcsine of x is 1 over the square root of 1 minus x squared. The derivative of arccosine of x is negative 1 over the square root of 1 minus x squared. And the derivative of arctan of x is 1 over 1 plus x squared. And I'm reading those as arccosine, arcsine, arctan, but you could also say inverse sine, inverse cosine, inverse tan. We proved the sine one, the arcsine one together. I left the arccosine one for you to prove, but you should be able to prove all three of these. And I'll do the arctan proof here. It works more or less the same as the arcsine proof. So let's let y be arctan of x, which tells us that tan of y then must equal x. Well, we can now take the derivative of this expression, so I'm going to take d by dx of both sides. The left side will require implicit differentiation, so we have secant squared, that's the derivative of tangent of y, times the derivative of the inside, that's the implicit differentiation step, times y prime, equals, okay, well the derivative of x is 1. Now we're ready to solve this whole thing for y prime. This tells us that y prime is then 1 over secant squared y. But we have a trig identity. If you recall, tan squared y plus 1 equals secant squared y. We're used to seeing this with x's, but it works the same if you put in y or theta or whatever. The trig identity still holds. So plugging that in gives 1 over, I'll write it as 1 plus tan squared y. But up here we decided that tan y is the same as x, is equal to x. So I can take this x here and plug it in for tan y, which gives us our final result of 1 over 1 plus x squared, completing the proof.